Okay, so we're going to do part of section 2 in chapter 9, the significant tests about a proportion. If you're going through your book and following along in your book, we are going to stop when we hit the part about power. So we are not going to go the whole way through this section. I just think it'll be too much at one time. Okay, so we're going to be looking at doing a significance test about a proportion. Keep in mind that your significance test is based off of your sampling distribution. Okay, so your significance test is going to be based off of your sampling distribution. Okay, we're using the significance test is going to use sample data to measure the strength of evidence for our alternative hypothesis and against our null. Okay, so we're using the sample data to measure the strength of the evidence for that alternative hypothesis and against the null hypothesis, because that's what we're looking to do. Okay, our conditions are very similar to what they were before when we did a confidence interval. So we have the same conditions of it needs to be random. We need our 10% sampling rule to come into play. Okay, and we also need our large counts. If you'll notice here, when you do your large counts though, your large counts is not based off of the sample. Okay, it does not come from p-hat, it does not come from the sample. It comes from that null hypothesis. Okay, later, when we construct a confidence interval, that will go back to coming from the sample. But when we're doing the significance test, it's all about the null hypothesis. So let's look at this first example here. Check the conditions for performing a significance test of the virtual basketball player's claim. Remember, that's the guy that has the claims the 80% free throws. Okay, so the first thing that we would need to check is whether it is random or not. Okay, and so these were 50 computer-generated shots. Okay, so we can assume that those are random. They were generated as a simple random sample. So since they were generated as a simple random sample, we're covered there. Okay, so then we would need to check our 10% conditions. Okay, so we are not actually sampling without replacement. There are an infinite number of shots that the computer could take, so we don't even need to check that. Okay, and then our large counts here, that's going to be assuming that that the null hypothesis is true. So for this case, our NP would be 50 times 0.8, not the 0.64 that we actually got from the sample, but 0.8, which is 40. And then we'd have n times 1 minus p naught, which is going to equal 50 times 0.2, which is 10. Both of those are at least 10. You'll notice it says at least 10, so both of them are at least 10, so we can assume normal conditions. So because we can assume normal, we can calculate our standard deviation, and when we calculate our standard deviation, we are going to calculate it using the null hypothesis. So we can calculate our standard deviation for this using the same formula we did before, but we would be using our null hypothesis to calculate that standard deviation. And we would get a standard deviation of 0.0566. So far, very similar to when we did a confidence interval. So using that information that we just did and worked through, we can use that to draw a normal curve with our null hypothesis as the mean. So we can draw our normal curve. Our null hypothesis is the mean at 0.8. Remember, our standard deviation here was 0.0566. So we can use this to draw our normal curve. I'm not going to try to cram each value in there because it will become just super messy. But if we look, we've got 3 standard deviations out, right? This is 0.8 plus 3 times 0.0566 and 0.8 minus 3 times 0.0566. And our sample would fall right about here, right? Remember, our sample was 0.64. So we can, just by glancing at this, we can kind of see that the likelihood of that hitting that many or less is going to be a pretty small probability. Okay, so our significance test is comparing our statistic that we calculated from our sample with the value of the parameter stated in the null hypothesis. So it's kind of the purpose of our significance test is to compare these two. And our statistic values that are far away from our null parameter value in the direction specified by the alternative hypothesis give us strong evidence against the null hypothesis. So let's kind of think about what that means. So our statistic values, let's say in our free throw thing, right, our null parameter was 0.8. Okay, and we were thinking that he hits less than 0.8 of those. So the further away that we get here, okay, the further, that's going to give us stronger evidence against our null hypothesis, the further away that we're getting from that parameter value. But to really check that, we need to standardize the statistic to assess really how far it is away from the parameter, to really be able to judge how far away from it is from the parameter. So when we standardize the statistic, this is what we're doing here when we calculate what we call this test statistic. Okay, so it is standardizing our statistic for us, and you have to show this when you are doing your work on your AP test. You have to calculate and show and state that this is your test statistic. Okay, and again, so your test statistic, I can't talk tonight. Your test statistic is measuring how far your sample statistic diverges or splits away from what we would expect if the null hypothesis were true. Remember, this is all about the null hypothesis. So if the null hypothesis were true, how far away is the sample really from it? How likely is that sample to happen if this, given that the null hypothesis is true? And you can use this to help determine your p-value. Okay, so let's look at this in our free throw example here. Okay, so in our free throw example, when we are calculating our test statistic, here, let me put that problem up for you. Okay, there it is. So when we are calculating the test statistic for this one, it's going to be our 0.64, that's our sample, minus 0.8, which is our parameter, divided by the standard deviation of the statistic. Okay, so 0.8, because remember we found standard deviation based off of the null hypothesis is what how we found our standard deviation. So this gives us a negative 2.83, which is equal to our z. Okay, so if we are looking at this on the curve, right, remember we're looking for the probability of this little tiny area right here. Right, we've got 0.8, 1, 2, 3 standard deviations out, 1, 2, 3 standard deviations out. We're pretty far out there. Okay, so we're looking for this probability here. We're looking for the probability that z is less than or equal to negative 2.83. Okay, I can plug this into my calculator to find that. Right, this is my normal CDF. Use that z-score to get my area under the curve there. My lower is something really low. Right, my upper is negative 2.83. And my mean, because this is a standard normal curve, remember? So my mean is 0 and my standard deviation is 1 when I type that into my calculator. And that will give me 0.0023. That 0.0023 is my p-value. That's my probability of this shaded little area right there. So 0.0023. So I have calculated my p-value. So what that means then, again, is if my null hypothesis is true. So if my null hypothesis is true and the player makes 80% of his free throws in the long run, there is only about a 0.0023 probability that he would make 32 or fewer of the 50 shots by chance alone, okay, which is just this little area right there. So again, if our null hypothesis is true, the player makes 80% of his free throws in the long run, then and there's only about a 0.0023 probability that he would make 32 or fewer of, because remember we have to add the or fewer because our alternative hypothesis is less than, by chance alone. And if you're still wondering, I just want to be clear on this, if you're still wondering where this mean of 0 and standard deviation of 1 came from, remember that I standardized and I calculated my z-score. So when I standardize and calculate my z-score, I can put that on the normal curve, right? And that tells me my z-score is way down here, negative 2.83. This is a mean of 0 because that's my standard normal curve. And I'm looking for that little area right there. So that's why you're using the mean of 0 and the standard deviation of 1 instead of a mean of 0.8 and the standard deviation of 0.0056. Okay, so let's get into actually calculating and performing the significance test. So when we're performing the significance test, we're going to do the same 4 steps that we did for a confidence interval. Okay, so the same steps, we're going to try to keep this very routine, okay, and just change little bits that we might need to. So the first thing we need to do is state, just like we did before, what hypothesis do I want to test? So this is where I would state my null hypothesis, as well as my alternative, as well as my significance level. All those things would need to be stated there. Okay, I need to define any parameters, and like always, I need to make sure that I've got context. Okay, make sure I use context when I'm defining these, if I'm defining parameters, when I'm stating what hypothesis I want to test. I can't just write that I have a null hypothesis of 0.8 and an alternative hypothesis of less than 0.8. I need to say that that's about free throws, that, that the claim is that he makes the 80% free throws every time, and we don't think that's true. Okay, so your next step, again, like before, is to plan. You choose your appropriate inference method. Just like whether you talked about whether you use the z-test before, or you use the t-test before. Okay, so not test. Okay, when you were calculating your interval, one sample z interval or a one sample t interval. Okay, so this time we would be talking about using a z-test, a one sample z-test for a proportion. Okay, so I need to state, some of you on your last test did not state that you were using the z interval, or that you were calculating the t interval. And then you'll need to check conditions. Remember that when you check conditions, you need to use your null hypothesis when you're doing your NP and your n times 1 minus p. You need to use that value, not your sample value. Okay, and then you perform your calculations. Again, you must perform that test statistic. Okay, that is almost always a point on the AP rubrics. So you need to be sure that you perform that test statistic. Okay, find your p-value, and then you need to make a decision about the hypotheses. Do you reject or do you fail to reject that null hypothesis? And you would need to say why, that you have convincing evidence or you do not have convincing evidence, and then make sure you put it into your context. Okay, so you'll be performing, so far, the only significance test we have is going to be a one sample z-test for a proportion. Okay, so if our conditions are met, okay, and we've set our null hypothesis to be whatever our parameter was, we have to compute the z statistic. So this right here, this is my test statistic here. I have to do this to make sure that I'm going to get credit, or full credit. Okay, so I complete my test statistic there. And then I'm going to find my p-value by calculating my probability using that z statistic. So if it's an alternative hypothesis where I think the true value is greater, okay, then I'm calculating my right tail. If it's a null hypothesis where I think the true value is less than, I'm calculating my left tail. Okay, and if it's one where I did not specify whether it was greater or less than, I just think it's going to be different, I need to calculate in both directions. So we're going to look at one-sided and two-sided examples. Okay, so this example goes back to the potatoes. Remember the potato chip producer that was going to decide whether he was going to accept or reject the shipment of potatoes based on the amount of blemishes. Okay, take a second and reread the scenario here so we can work through it. Okay, let's run through each of the 4 steps because you need to do all 4 of them to make sure that you are always getting the right amount, all the credit, the right amount of credit. Okay, so the first step is the state part. Okay, what are we going to do? What do we want to do? So what we want to do is perform a test. So we're going to perform a test and we're going to set up that null hypothesis and that alternative hypothesis. So we want to perform a test of the null hypothesis being p equals 0.08, the alternative hypothesis being p is greater than 0.08. Okay, and then I need to define what p is. Okay, again, if I don't do this, I may not get full credit. So I need to state that where p is my actual proportion of potatoes, because I'm going to put it in context, right, of potatoes that are in the shipment with blemishes. With blemishes. Okay, I know that these answers can be a lot of writing and they can be pretty lengthy, but you're going to be expected to do these things to earn your full credit. Okay, so, and then I need to make sure that I have defined my alpha, my significance level, and I haven't done that. Okay, so to be a complete answer here, I need to state that we will use this one gave me an alpha. If it did not give me an alpha, then I probably would still go ahead and use 0.05. Okay, with an alpha equals 0.05 significance level. I'm running out of room. Okay, and so from there, we would move on to step 2, which would be the planning part. So in the planning part, let's get rid of all this. All right. So in the planning part, we need to say what we're going to do or what test we're going to use. So we will use a 1 sample z test for a proportion. So I'm using a z-test for a proportion here. And then this is the part where I would go ahead and check my conditions. So there are 2 things I do in the planning part. I use a 1 sample z-test for a proportion if the conditions are met. So I need to see if I need to even move on to my doing part and my conclusion part. I need to go ahead and I need to check my conditions. Okay, so it was random because it said that it was an SRS. So we can assume that it's random. As for 10% conditions, we took a sample of 500, which means we needed at least 5,000 potatoes. So we can assume that there are more than 5,000 potatoes in that shipment, which is probably a pretty logical assumption. Okay, and then we need to do our NP, our large counts, right? We need to check our large counts, our NP, and our N times 1 minus P. Remember, that's based off of the null hypothesis. So NP would be 0.08 times 500. Yes, I know those numbers are backwards. Okay, which is going to be 40. And our N times 1 minus P would be 500 times 0.92. which would give us 460. Both of those are greater than 10, so that condition is met as well. We can assume normal. Okay, so we've checked our conditions. We've told that we're using a 1 sample z-test for proportion. So now we would move on to the actual doing part. So remember, when in the actual doing part, that, go away. Okay. In the actual doing part, that we need to be sure that we show that test statistic. So in this instance, our test statistic, our standardization here, is going to be our sample minus our null hypothesis over our standard deviation. So 0.08 times 0.92 over 500, which will give us 1.15, okay, which is basically that is our z-score, right? So that means I can put that into a normal curve, a standard normal curve, and I can find the probability there at that z-score. So basically what I'm looking for now, my p-value is going to be equal to the probability that z is greater than 1.15, because remember I'm looking to see if it has more than 0.08 blemishes, percent of probability of 0.08 for blemishes. So I can go ahead and put that in my calculator. Okay, my normal CDF function with my lower being 1.15, my upper being a big giant number, and then again my mean is equal to 0, and my standard deviation is equal to 1, Okay, and so what that will give me is a p-value of 0.1251. That is my p-value. Okay, so now I can finally go on to the conclusion part. And again, our conclusion part, remember, like always, is going to need to be in context. So for the conclusion part here, it's going to be long. All right. So because the p-value, and I need to go ahead and state it, 0.1251, is greater than the alpha equals 0.05, we fail to reject the null hypothesis. There is not, and this is a must thing, you need to say it this way, there is not convincing evidence that the shipment, and here's all my context, okay, that my shipment contains more than 8% blemished potatoes. As a result, they will use the shipment to make chips. Okay, so then I'm going to run out of room for that. They will use this shipment to make chips. They will use, let's just do this. They will use the potatoes. Okay, but they will use that shipment to make chips. What you cannot do is you cannot say anything that implies, okay, do not say anything that implies that you believe that the alternative or that the null hypothesis is true. This is how you word it. There is not convincing evidence. You do not say anything like the shipment is okay, because that implies that you think that the null hypothesis is true, that you think that that there is less than a 8% of the potatoes have blemishes. So, or that 8% of the potatoes have blemishes. So again, remember we talked about this in the first section. You never, ever, ever say anything that implies that you believe that the null hypothesis that is true. If you state that there is not convincing evidence that the shipment contains more than 8% blemishes, that does not mean that you think that it does, that the null hypothesis is true. It just means that you couldn't find enough evidence to kick it out. Okay, so make sure you don't do that. Okay, let's look at two more things and then we'll be all set. Let's look at a two-sided test and then we'll build a confidence interval. So we're looking at a two-sided test. So this would be one, remember, where our null hypothesis is just, or our alternative hypothesis is that it does not equal. Not that it is greater than or less than, but just that it does not equal. So take a minute to read this problem and then we'll work through it. Okay, so I'm not going to necessarily write word for word down. I will say word for word, but to kind of speed this one up a little bit, I'm not going to write word for word. Okay, so the first thing that we need to do is our part one, right? So in our part one, We need to state that we're going to do a significance test. Okay, and we need to state those null and alternative hypothesis. So for this case, it would be, the null hypothesis would be p equals 0.5. Okay, he didn't specify whether he thought, oh, don't do that, just like I make that mistake every time. He did not specify whether he thought at his school it would be greater than or less than. So our alternative is just that it does not equal 0.5. I need to state out where P is, and this is my context, right? P is the proportion of all students at Tayon's high school that would say they've never smoked a cigarette. Okay, so add that context there. And then I also need to put in what my significance level is going to be. And since 1 was not specified, we'll go ahead and go with a 0.05. Okay, and then as we move on to step 2, so step 2 would be our planning. So for my planning here, I need to say what I'm going to do, right? If those conditions are met, right, I'm going to do a 1 sample. This is still only a 1 sample. Even though it's two-sided, it's still only 1 sample. I'm going to do a 1 sample z-test, okay, for the population proportion of P. Okay, and then I need to go ahead and check all my conditions. It's random because they said it was an SRS of 150. My 10% conditions are met because we're going to assume that my student population is greater than 1,500. And then my NP, my large counts. Again, my large counts, remember, they're if my null hypothesis is true. So it's my sample times my null hypothesis probabilities, right? And if I did my sample 1 minus, I get the same thing, 150 times 0.5. So both those are greater than 10, so I can do normal calculations. So when I go ahead and go to part 3, the actual doing part of the problem, okay, my p-hat in this case is 90 over 50, which is 0.6. Like I said before, we have to calculate we have to show that we know what that test statistic is. That's standardization, basically that z-score. Okay, and I need to put that over my standard deviation using my null hypothesis. I have a sample of 150, and this gives me 2.45. Well, I didn't say greater than or less than, so I need both tails. I need the probability that z is less than 2.45, and I need the probability that z is greater than 2.45. So when I find that p-value, okay, I need to go ahead and double it. So if I put this in my calculator under my normal CDF, I can put it under either side. Let's go ahead and do the lower being 2.45. So my upper is a really giant number. Excuse me. My mean is 0. My standard deviation is 1. And that's going to give me 0.0142. So that's the area down here. Okay, that is 0.0142. Well, they're going to be the same, so I need plus another 0.0142, and I get my total p-value of I'm sorry, hold on. I was giving you wrong numbers. This one is, I apologize, 0.0071, and so that means I need to add those together up there. 0.0071, so I need to get that off the other side too, and that gives me a total p-value of 0.0142. So this is my p-value because it takes in both of those areas into account. We'll talk about a little bit later, we'll talk more about how to do some of this stuff on the calculator, and when you put it in on the calculator, you won't need to double it. It'll go ahead and give it to you already doubled for you. So now you need to do the last part, your conclusion. So my conclusion needs to be in context. I need to make a decision about my hypothesis. So my conclusion here, I've got a p-value. So because our p-value is 0.0142 is less than, and alpha equals 0.05, then we are going to reject the null hypothesis. So it is less than 0.05, so we reject the null hypothesis. This time, I say that we have convincing evidence. So we have convincing evidence, and then we go ahead and we put all of our context in here. We have convincing evidence that the proportion of all students at Tayons High School who would say that they have never smoked a cigarette differs from the national proportion or the national result of 0.5. But it's a lot of context, and you need to put it all in there. Then we have convincing evidence that the proportion of all students at Tayons High School who would say that they have never smoked a cigarette differs from the national result of 0.5. Okay, so now that I reject the null hypothesis, what if I want to get an idea of what the actual proportion is at his high school? Well, then I could I can calculate a confidence interval for that and try to determine what that would be. So if we're going to conduct a confidence interval for this, we've done the conditions already. However, we need to go back and we need to recheck our large count conditions, because remember, when we're conducting our confidence interval, our large count conditions are based off of the samples. So this time I would have 150 times my sample proportions as opposed to my null hypothesis proportions. And in this instance, they are both still greater than 10. I had 90 people say that they had never smoked, and then 60 that said they did. So I'm greater than 10. So I do need to double check my large counts because it was different. But then I can go ahead and I can calculate my confidence interval. And I'm going to calculate a 95% confidence interval. So remember, I've got my sample plus or minus my 95%, so my critical value of 1.96 times my standard deviation. Again, I'm doing a confidence interval, so you'll notice I'm using my sample proportions, not the null hypothesis proportions. And this is going to give me the interval 0.522 to 0.678. And then we'd interpret this the same way we would have before. We are 95% confident that the interval 0.522 to 0.678 captures, so the same as we did before, we're 95% confident that the interval 0.522 to 0.678 captures the true proportion of students at Tayons High School that would say they've never smoked a cigarette. Okay? You'll notice it gives very similar information to a two-sided test. So if this is my interval right here, okay, and I can use this interval to help me decide if I want to accept or reject, right? 0.5 is not a plausible value in that interval. So I could use this to say that I would reject that because it's not a plausible value in my interval. I can only do this for a two-sided test, and I need to make sure that my interval that I'm calculating is the same as what my alpha was set for. Okay, so we're going to stop in the section here if you're following along in the book, and we'll pick up power later. I think that's going to be more of an on its own thing.